Hello students, and welcome to our second lesson on volume. Today we're looking at tapered solids and spheres. So a tapered solid, we'll note, is just something that has a taper on it or an angle. It comes to a point like a pyramid. So it could be a slant pyramid, it could be a pyramid, and spheres, of course, are rounded. So the job of today is to calculate the volumes and capacities of standard three-dimensional objects, including spheres, cones, pyramids, and composites in practical situations. So the important formulas to remember today is the volume of any pyramid is essentially a third of that of the equivalent prism. So the volume of a pyramid is a third of the area of the base times the height. The volume of a sphere is 4/3 pi r cubed. So you'll notice that it's got a cubic unit there, so don't get confused with the total surface area formula when we look at them in a little while. So the volume of a sphere is 4/3 pi r cubed. Well, that follows then that the volume of a hemisphere, which means half of a sphere, is just 2/3 pi r cubed, because 2 here is half of 4. If we have a look at them in a little bit more detail, so we've looked at the prism formulas. Now, I just want you to know, a cone is the pyramidal form of a prism. A square pyramid is the pyramidal form of a rectangular prism, for example, or a cube even, and a rectangular pyramid is that of that, and a triangular pyramid is the pyramidal form of a triangular prism. So the volume of a pyramid, in this case, it has a taper, so it has this slant here. It's just a third of the area of the base times the height. Now I'm going to go straight into a combination question here. So this is composite or compound questions, and something else that's close to my heart is ice cream. So how much ice cream can I cram into a cone with the following dimensions, assuming I make a perfect hemisphere on top? So I'm cramming all the ice cream all the way down to the bottom, so the joy lasts for a long time. So we have to calculate the volume of the cone plus the volume of a hemisphere. Now, we've got the volume of a cone, which is a third of the area of the base times the height. So that's our formula for a pyramid, times a half of a sphere. I could have just put that and put a 2 there, for example, but that's all right. So we're just going to substitute in now. So we're solving our problem. It's a third of pi times 2.5 squared. So that's our radius from there to there, times 2.5 squared times 10 plus that of a cone. So 2/3 pi r, r is 2.5, and we're cubing that. So we're saying 65.44 cubic centimeters plus 32.72 cubic centimeters will give us a total of 98.165 cubic centimeters, and we can communicate that to capacity now, because remember, this measures volume and this is capacity. So 99 mils of ice cream can be jammed into that sort of cone.